Welcome to the presentation of From Angel to Series C, Assessing a Startup's Funding Opportunities. This presentation is brought to you by Viet Trinh, An Pham, Nguyen An Lu, Minh Nguyen Lu, Nguyen Nguyen Huynh, and Quan Huynh. The authors are affiliated with the University of Economics and Law and Vietnam National University, located in Ho Chi Minh City, Vietnam. In their early stages of development, startups typically navigate through several funding phases: angel or seed, Series A, Series B, and Series C. Accurately determining a startup's potential for growth and identifying opportunities for future funding presents significant challenges. From the perspective of entrepreneurs, it is challenged to clearly identify and effectively articulate a startup's intrinsic strengths, as it directly influences the company's prospects for long-term survival. Conversely, from an investor's standpoint, a comprehensive understanding of a startup's core competencies and operational dynamics can substantially enhance confidence in making crucial investment decisions. Existing research efforts have shown limited capability in leveraging advanced deep learning architectures to capture the intricate temporal and structural dynamics inherent in startups. Lacks comprehensive platforms that effectively integrate data inputs/outputs with interpretable predictions for practical business applications. To address these limitations, AI-based funding assessment system, ICFICE, automatically analyze a startup's investment financing. Semantically encodes previously funded activities, providing a richer data representation. Logically predicts the likelihood of securing subsequent funding rounds, offering actionable insights. The system is designed as an interactive platform, enabling entrepreneurs to conveniently input their startup's investment data through a chat interface. This picture shows the AI-based funding assessment system pipeline. Investment financing information and data from the board of directors, encompassing 6 different primary factors, are systematically encoded into color spectrum bars. This unique visual representation of a startup's financial profile then serves as the primary input for the deep neural network. Specifically, this encoded information feeds into a fine-tuned UNet++ deep neural network. The ultimate output of this sophisticated process is a precise prediction regarding the next rounds of funding a startup is likely to secure. The primary dataset employed in this study for data encoding is the Crunchbase 2013 snapshot. Provides a wealth of information about the startup ecosystem. Includes detailed information, key individuals involved, relevant company news, historical funding rounds, acquisitions, and initial public offerings, IPOs. For the purpose of this analysis, specific primary features were carefully selected. The educational background. Entrepreneurial experience of the founders. The number of financial investors involved in the startup. The amount of capital that has been invested in the startup. The prior funding status of the startups is included as a key feature for analysis. In the data encoding process, the selected features are systematically grouped based on their semantic similarity, weighed according to their significant impact on the success of subsequent funding rounds, encoded into a series of distinctive color stripes. Within each stripe, the width of a section represents the relative importance of the corresponding feature. The vertical composition of these individual stripes collectively forms a comprehensive visual representation of a startup's investment financing profile. Our system is structured as an integrated, dual-component framework specifically designed to facilitate comprehensive investment analysis and accurate prediction. This system comprises 2 primary components. The interactive analysis component, a chat-based interface that is responsible for collecting critical information related to investment financing and relevant stakeholders. The funding prediction component, is specifically tasked with generating pixel-wise encoded investment profiles and subsequently forecasting potential funding opportunities for startups. At the core of the funding prediction module lies a fine-tuned UNet++ neural network, which is the engine behind ICFICE's predictive capabilities. This network is specifically engineered to assess and compute the likelihood of subsequent funding rounds for startups, including the incorporation of an adaptive average pooling layer. The fine-tuned network underwent training over a period of 30 epochs. The Atom optimizer was utilized during the training process, with a learning rate set at 1 × 10⁻3. The input data was processed in batches of 16. The dataset employed in this research initially comprised approximately 700,000 data records. Each of these records distinctly represented a specific funding round associated with a startup, and they were meticulously organized in chronological order. The data encoding process involved aggregating these individual records by company. This aggregation process ultimately resulted in the successful creation of over 5,000 unique investment financing profiles. The primary objective of this fine-tuning process was to predict the probability of forthcoming funding rounds for startups. During the fine-tuning process, several key observations were made. The training loss diminished from approximately 1.10 down to 0.35, indicating effective learning. The validation loss also showed a significant decrease, moving from 0.88 to 0.30, demonstrating good generalization. The training accuracy notably improved from 0.60 to 0.90, reflecting the model's increasing ability to correctly classify training data. The validation accuracy enhanced from 0.65 to 0.92, confirming its strong performance on unseen data. The model achieved an average training loss of 0.5576 and an average validation loss of 0.4936. The mean training accuracy reached 0.8156, while the mean validation accuracy stood at 0.8473. The model demonstrated particularly high accuracy in identifying predominant funding categories. Correctly identified 33 out of 34 Series A samples. For Series B samples, the model accurately classified 46 out of 47 instances. In the Series C category, a remarkable 121 out of 127 samples were correctly identified. However, for minority categories such as angel and seed, some degree of misclassification was observed. Within the angel category, 9 out of 11 instances were accurately classified, but 2 instances were erroneously categorized as Series A. For the seed category, 5 out of 8 instances were accurately labeled, while the remaining 3 instances were misclassified between the angel and Series A categories. One significant challenge encountered is the black box problem, where deep learning models often provide predictions without clear, understandable explanations. It is crucial for both entrepreneurs and investors to fully understand why a particular prediction is made, necessitating future work on explainable AI, XAI, integration. Another challenge stems from data scarcity for extreme cases, such as unicorn startups and IPOs. Since unicorns and IPOs are rare events within the available dataset, the model struggles to learn reliable patterns from an insufficient number of examples. Addressing this requires the exploration of alternative strategies or the collection of more diverse and extensive data specifically for these unique scenarios. Looking ahead, there is an anticipated public release of ICFICE, aiming to make this valuable tool widely accessible. Future integration methods are being considered, including its availability as a web extension. Additionally, ICFICE is planned for release as an API integration, allowing for broader application. The overarching goals of these efforts are to enhance accessibility for a broader user base and to significantly broaden its functional scope. Ongoing research is dedicated to addressing the current limitations of ICFICE, with a particular focus on improving interpretability and handling outlier cases more effectively.